Hey everyone, I'm Michael Hall, and you are watching Innovation Coffee. Hey everyone, I'm Michael Hall, and this is Innovation Coffee brought to you by ARM. Every week, we take you on a deep dive into the ARM developer ecosystem with special guests and topics covering the latest innovations happening in, around, and on the ARM architecture. Here at Innovation Coffee, we encourage audience participation. So if you have any comments or questions that you want us to include in the show, go ahead and drop them into that YouTube chat for us. We've got another great episode for you today. I'll be joined by John Ceccarelli, the Senior Director of Product Management over at Azul Systems. They're one of the major players in the modern Java ecosystem, and we're going to be talking about the latest developments happening over there and Java on ARM a little more broadly. But before we do that, just remember that if you like this episode and you don't want to miss out on future ones, make sure you click that like and subscribe button below so that you always see the latest broadcasts coming from the ARM software developers, including Innovation Coffee and ARM TV. Now, last week, Robert and I were at KubeCon North America over in Chicago, and we did several special brew episodes. So if you missed those, you can check those out on our YouTube channel as well. We had some episodes with special guests happening in our booth. We also had Robert do a walk around of our booth and part of the expo hall floor. So if you weren't at KubeCon and you want to see what that was like, go check out those videos. We also did a number of interviews with some of the key players in the cloud native ecosystem. We're going to be working on those videos, so doing post-production on those before we release them, but that's something for you to look forward to as well. Now, I mentioned my guest today is coming from Azul Systems. Azul is a company who provides a Java JVM and platform. And I know because I saw them at DevNexus talking about this, that they're doing some optimization work within the OpenJDK specifically for ARM, plus a lot of other really interesting innovations. So I'm really excited for this episode. So we're going to go ahead and bring John in. Hey, John, welcome to Innovation Coffee. How are you today?
Doing great. Thanks for having me.
So to start us off, tell us who you are and what you do over there at Azul.
All right. So I'm John Ceccarelli. I'm a Senior Director of Product Management over here. And at Azul, we have two major JVMs, and I run one is a supported build of OpenJDK, which is just vanilla OpenJDK, and one is the high performance, highly tuned JDK. So I run the high performance side of the house, but I've got my fingers in lots of pies over here.
So let's take a step back, because a lot of people coming from like maybe Java, or sorry, not Java, like Python or I don't know, Go or Rust, they might not be used to having these different virtual machines. So there's the OpenJDK, right, and then there's what Azul does. So what is Azul making, and how does that relate to OpenJDK?
Right. The OpenJDK landscape is actually really interesting, and it's gotten even more interesting lately. So I mean, the JVM, Java Virtual Machine, Java, you have Java, the code, the language, you write a program in Java, and then you need to run it on something, and that's the JVM, which we often use JVM and JDK interchangeably, right? And the Java Virtual Machine, the JDK is open source, so it lives at OpenJDK open source project, and then various organizations have their builds of those, right? So Oracle sells its version of OpenJDK, and Amazon Web Services has its version, which is called Corretto, and so forth, and Azul actually has two versions of that. So one of it is the platform core, also known as Zulu, right? And this is just the standard build that is in every single way exactly the same as every other as the source code of OpenJDK, and that one is just a supported build of OpenJDK. And then what we also have is Azul Platform Prime, also known as Zing, right, which takes OpenJDK and actually makes some changes. It actually replaces some things and basically gets you higher performance, lower costs, and so forth out of it. So yeah, it's an interesting time. It's an exciting time right now, with different people bringing different builds of OpenJDK together, and also kind of contributing to what's in the JVM with different components. So you see things like the Shenandoah project, coming in from Red Hat, I believe it was, and then we contribute other things. So each of the people who are building the OpenJDK are also sponsoring different pieces that would go into the central OpenJDK. So it's an interesting time for Java runtimes, that's for sure.
It certainly is. So way back when dinosaurs roamed the earth and I was a Java developer, there was Sun Java, and then there was IBM had their own Java, and that was it. That was before the Oracle acquisition and before OpenJDK. So when did Azul start, and what was the reason for this company starting?
Right. So Azul started, we've been around for 20 years, actually, if you can believe it. I haven't been here the whole time, but the company has been around for 20 years. We've always been, the company started out really in the high performance Java space, building high performance, low latency Java systems mostly for trading companies, for high frequency trading on the web. And the company actually used to build an appliance. We actually used to have a server, right, with the architecture tuned specifically to our version of the JVM, and we would actually ship you this box back in the day.
Okay.
Yeah, it's pretty wild. Over the years, then we've gotten out of the hardware business and just been into producing JVMs, and the JVM that came out of that was called Zing, and was later rebranded to Azul Platform Prime, although we still affectionately call it Zing. And again, really, it was the first one that really introduced pauseless garbage collection. So pauses for garbage collection are a big deal in Java. This is what, if you're trying to maintain consistent execution through the life of your product, right? Through the life of your trading day or whatever, right? You want to make sure that you don't have any outliers, that everything is running at the exact same speed. Well, the main thing that would get in the way of that is if, when it's time to do garbage collection, the runtime pauses all of your application threads, does all the garbage cleanup and so forth, and then says, okay, now you can go again. Well, any transaction that was waiting for that to happen is going to have an outlier. So we invented pauseless garbage collection, in the Java space, and now there's lots of different approaches to it. Shenandoah, ZGC, RC4 is still very big in there. And then, interestingly, at a certain point, Microsoft came to us and said, we want you to build us, we want to have a supported build of OpenJDK on the Azure platform, but we don't want to build it ourselves. Would you build it and support it for us? And so for a long time, we were Azure's default open, JVM that you would get on Azure. We also started selling that to people who wanted to get off of Oracle, but still wanted to be on a supported JDK. And so yeah, we've kind of now in two spaces. If all you're looking for is just vanilla, open Oracle replacement or a supported build of OpenJDK, we can give you core. But if you want a high performance JVM, then that's prime. And we've gone way beyond posless garbage collection, into things like the JIT compiler, which I'm sure we'll talk about.
Yes, absolutely.
Yeah, and things like warm-up optimizers like Ready Now, and then the Crack project that we're sponsoring now that is seeing some real uptake. So yeah, a lot of innovation in the JVM space, and it's fun to be a part of it.
So I found out about Azul at DevNexus earlier this year. Somebody was giving a talk, and one of the things they talked about that really, piqued my interest was some of the optimizations going into OpenJDK to improve its performance on ARM. Can you tell us a little bit about what those optimizations are and what Azul's role has been in getting those into the OpenJDK project?
Right. So actually, we don't contribute. So most of our ARM optimizations have been happening on the prime side into our own JIT compiler, and haven't really made it back into the hotspot compiler in OpenJDK because they're different architectures. And what we've been doing though is when we brought our prime product to ARM64. The interesting thing is when you're trying to release Java, a JVM for this new platform, there's one part that is done, and then there's one part that's kind of never done. So getting it to just work, to make sure it's TCK tested, which means that everything that is supposed to work in the platform actually works. Making sure that everything is, that it's not going to crash, that it starts up and so forth. All of that obviously is groundwork. But then there's the optimizations, right? And the optimizations are something that I think, we keep improving on both on our side and interestingly in the OpenJDK side, and also on the various chip makers that are bringing out their platforms. So we've had the JIT compiler, for people who don't know, right? The JIT compiler is basically the engine of how fast your Java code is gonna run. So what the JIT compiler does is it takes this portable bytecode that is Java that can run anywhere, and then it says, okay, I'm not running anywhere. I'm running specifically on this hardware, this chip hardware, and so forth. And then it on the fly compiles that down to machine code to optimize machine code that will run as fast as possible on that specific architecture that it's running on right now. And so, we've been the x86 architectures, we've had a long time to optimize for those things, both OpenJDK, Prime, all of the Java, and ARM64 is relatively new, right? So it's been interesting. Like some of the things we've done is like we do a lot of benchmarking, and so when Graviton 2 first came out on AWS, for example, we benchmarked some popular Java performance benchmarks on like the comparable x86 and ARM64, AWS instances, and we found that the Graviton 2 was actually quite a bit slower, actually, which was interesting because you've got, if you look at it and you say, oh, I'm running Java on x86 and it's costing me this much, and my ARM64 and my Graviton 2 instance is 40% less, that means I'm going to save 40% on running my Java workloads. And that's actually not quite true, because you have to factor in, okay, the JVM is 40% cheaper. I mean, the instance is 40% cheaper, but Java on this instance can handle less transactions. That means to handle my entire amount of traffic, I'm going to actually need a couple more instances. But they closed that gap very quickly. AWS with Graviton 3, we saw that gap go down to almost zero. And the same thing with us, as we were going through and bringing it through. From Graviton 2 to Graviton 3, and with later releases of Java, we're able to really get the same performance gains that we see on x86 on the ARM64 instances.
And I know part of that is as the new, the new Neoverse designs come out that Graviton uses. We've got intrinsics there that can speed up specific optimizations, and then the Java JVM or the JIT compiler can start taking advantage of those, and that'll help the speed up too. Which kind of leads to my next question: is what were some of the challenges that you faced, or opportunities maybe, when you started optimizing your code for ARM?
Yeah, I mean, I think it was just really just going through and finding all the places and then fixing them. I think the challenge is what the challenge always is, which is you can only optimize what you can see, right? And so, we probably have the widest set of Java benchmarks that we run continuously, of anybody in the business. But still, like, you've got a bunch of, JMH, JMH micro benchmarks, right? It's very hard to imitate the full range of code that people are running in the wild and all the code patterns that people are running in the wild, locally. So really, I think that the main thing has been just trying, once you find a gap between, how fast something runs on x86 and ARM64, there's usually, no big mystery or science behind it. Occasionally you will run into, and then the other thing is it's not like level. It's not all the way across, right? Like, here's 100 benchmarks. They all ran this fast on our x86. They all ran 10% slower. It's like, no, there's actually, these ones were, it's an S curve, right? Of like, these ones were slower, these ones were faster. And some of those things have to do with just, the architecture can do things like vectorization and so forth. The ARM64 architecture can just do that much more efficiently, right? So yeah, it's been an interesting journey for sure.
All right. So I do want to jump in and start talking about your JIT compiler, because this is one of the things I remember from DevNexus, is that whereas Hotspot will look at, the Java bytecode that's executed frequently, and it'll just do like a literal translation of that to native instruction code. Your JIT compiler is a little bit smarter than that, isn't it?
Right. So, I mean, it's interesting. So the way a JIT compiler works is, it wakes up, Java wakes up, it starts executing code, and every time it wakes up, it's like a new run. It has no idea about any time this code was executed in the past, in the future, or whatever. So it wakes up and it starts executing this code, and it just starts looking for places that are getting called a lot. Yeah. And then it starts profiling that code it computes it to what we call tier 1, which runs a little bit faster than interpreted mode. And mostly tier 1 is all about profiling, and it starts profiling. It starts asking a bunch of questions. How are you using this code? How are you doing this code? So that it can figure out what is the best way to optimize it. And this is both Hotspot and our JIT compiler, which is called Falcon. Hotspot is OpenJDK, right? And ours is called Falcon. And then it'll go through the process of like, okay, let's compile this thing, right? And so, and it'll start compiling it. And that takes a lot of CPU, right? So when your CPU curve, when you start a program is usually like womp, and then it comes back down to some steady state, right? And mostly that womp at the beginning, that's JIT activity, right? And you'll see that curve takes a while because it has to wait for all this code to get executed, right? A certain amount of times before it can figure out that profiling information, right? So it can figure out not just what to optimize, but how to optimize it. And a lot of people, this is a problem. This is especially a problem when you have lambdas, when you have serverless, when you have automatic, scaling, horizontal auto scaling,
And it's been a criticism of Java for as long as I've been doing Java, like from back in the like late 90s, even that startup time.
Yeah, I mean, the whole like Java is slow. Java is not slow. Java is just compared to a statically, compiled, language. It's slow to get to full speed, right? And then especially if you compare it against something like Node, it's way faster than Node, right? But Node is the first transaction you run through Node is going to be the same speed as the last transaction you
Right.
run through. And lots of people have tried to solve this in different ways. And so we've got a lot of different things that we do. We're like, why is it that every time the application, the JVM starts up, it can't remember anything about it? It's kind of like the JVM is kind of like that guy from the movie Memento that can't remember what happened 5 minutes ago, and he keeps waking up and going, well, what am I doing now? Oh, I guess I'm running this. Okay, let's figure it out, right? But it's run that app 1,000 times before, right? It's probably running in a fleet of servers where 100 other servers are running that app right now as we speak, right? So why is it having to go through a profiling stage at all? It should already know exactly what kind of optimizations it needs, right? And so that's why we built in this technology called Ready Now, which basically it just that whole profiling process, it just spits that out and saves it somewhere, right? And it saves it in the Optimizer Hub, which we'll talk about, right? And so it'll spit that out, and so the next time you start, it know right off the bat, okay, these are the things I need to optimize, and start optimizing them immediately. But the other question is, as we're running on smaller and smaller containers, and we just don't have a lot of CPU to devote to that CPU curve, why are we doing JIT on the CPU at all? We live in a cloud world. We offload things all the time to different places, right?
Right.
So we built it called right.
This is kind of a major shift for the Java community, I think, because it used to be you had monolithic servers, JBoss or WebSphere, and you ran them on some powerful rack server, and it was all about uptime. Like you got the app up and running, and it just didn't stop. And so having that JIT compiler that would run, just in that process, optimize for that process, and not have to worry about, saving that optimization state between runs, it made sense then. But the way people develop programs has shifted. With the introduction of cloud computing, all of our mentality has shifted. So now it's all about running super small, running super fast, and being kind of ephemeral. So you are shutting down a service and spinning up a service, and so that's really changed what the JITs need to do in Java. And I think this leads us into what you were going to talk about is your cloud native compiler, right?
Right. Yeah, I mean, totally. And even if you think about like the technology we were working with, everything was stateful back in the day, right? Yeah. So you didn't want to restart your server, right? Restarting your server was death. You had to recreate all that.
Right in our uptime, right? Like how long has my server been running?
Right, exactly. So back then, like JIT was like, okay, I do it once, every once in a while, right? This was also before CI/CD, right? This was before, we were, that was back when we, released the server 3 times a year. If that was like a super agile, thing, right? Now we're like, it's 7-8 times a day deploying code changes and rebooting your entire fleet, right?
And they're all microservices. You've got dozens or hundreds of instances running out there in Kubernetes.
I think people have gone fairly nuts with the microservices. I think we've gone a little fairly nuts. I mean, I think people are trying to like one REST API equals one JVM equals one REST API equals one JVM. It's just kind of like, I just think we're wasting a lot of resources, right?
It's that pendulum we see all the time in tech, isn't it?
I know. And I think people are starting to swing back. They're starting to see the whole complexity of it, but also the cost of, and one of the big pieces of the cost, especially if you're in serverless, right, is I got to start this thing up and shut it down and start it up and shut it down. And every time I start it up, what's happening? I'm spending CPU on, all those JIT cycles, right? So to bring us back to, how one of the ways we're looking at the problem is, we said, everything's running in these big containerized fleets anyways, right? Usually on Kubernetes, right? So, and they're already, talking to each other for things. So let's build this thing called Cloud Native Compiler, and it sits inside of Optimizer Hub. So Optimizer Hubs, it's just a Kubernetes, it's a Kubernetes container. You just deploy it to Kubernetes, and It has some services that the JVMs can hook into in order to be able to offload some of their work and share intelligence. So one of the things they do is all those ready now profiles that tell you what actually needs to be compiled. Some subset of your fleet will upload all those up there, and Optimizer Hub will look at all those and it'll go, okay, based on my knowledge of what this whole fleet is doing, this is what I think the optimal performance profile is for this workload right now. And then we've got these compilers, right? So these cloud compilers, the CNC. And the important thing there is, yeah, you need a lot of CPU compute power. And it seems like it's a lot, right, to warm these things up, but you only need it for like very short periods of time. And it's great when you have an elastic cloud, you have a way to suddenly burst up, a bunch of compilers, vcores, for 5 minutes, or for 20 minutes when you're doing a fleet restart, and then shut them down to nothing. And overall, the cost of it is fairly low. But even more importantly, if I've got one central location that's doing compilation for an entire fleet, right? And all those fleets are compiling the same things over and over again, right? Well, now I can put a cache there, right? Mm-hmm. And now instead of actually having to compile it every single time a new JVM warms up, I can, when I get asked for a particular compilation, I can go find it in the cache and serve it up, which reduces, both the time it takes to warm up and the time it takes to warm up and how much you're spending on the server to actually perform those compilations.
So for me, that's really cool because these ARM server CPUs, they tend to have a lot of cores, and so you've got that's a resource you now have a lot of, and then you can dedicate just some of those to this JIT compiler and have it serve every other container that you've got running there. Coming from, again, my background back in the early days of Java, that's a really exciting innovation for me.
Yeah, it's fun. We've learned a lot along the way. I mean, it's been we are pushing the limits of Kubernetes scalability because the amount of time that you have, the nice thing about these JIT compile cycles is that they're fairly short. The bad thing is because they're fairly short, you got to get those resources up and running to serve them like really quickly, right? And so yeah, we're constantly pushing the boundaries of what cloud can do to bring up large amounts of those resources. And there's so much fantastic innovation happening on all the major cloud providers in that area. This whole, it's not just a Java problem. This whole scalability thing is not just a Java problem. It's like, if it takes you 2 minutes to start up, a new, if it takes you 2 minutes to start, new instances of whatever you're running, I don't care if it's Java, Node, whatever. If it's a new container takes 2 minutes to start up, right? Well, then you can't be truly reactive, right? Because like if your load, it just means that we're all spending a bunch of money over provisioning stuff in the cloud because it's, if I have a spike in traffic right now that needs to get served right now, it's very hard to wait for 2 minutes. So for resources to be brought up to deal with that. So I think, everybody's still pushing on that. And part of that for Java is definitely warm up, and that's where we're kind of at the forefront.
So you mentioned, all these major platforms now. Every major cloud provider's got ARM nodes, and they all seem to be pushing for migrating workloads off of x86 and onto these ARM servers. So given that, where do you see the future of Java and development of the JVM going in the future?
Right. I think one of the considerations, as far as Java, one of the considerations is getting the full spectrum of functionality, working on all of the ARM64 based offerings that the cloud providers are giving. some of the cloud providers may be providing like ARM64 based, like vanilla, images, or instance types, right? But if you want an IO, optimized one, or if you want a network optimized one, or, some of the more specific instance types that people really want when they're running something that is more IO bound than compute or memory bound, right? And until that full offering is there, I think the migration of Java workloads to ARM64 on the clouds will be limited, but that's just a matter of time. As far as the JVM goes, there are lots of very interesting projects happening inside of OpenJDK to make there's some interesting projects to make Java just take less resources, take less memory. There's projects inside of OpenJDK. And I think what we're going to see is we're going to see more and more innovation and also more innovation, what we've always seen in Java, which is innovation happening outside of OpenJDK. And then once it gets settled and stabilized, then it gets brought gets standardized and brought in. We've seen this over and over again. We saw it, to get a little bit into the Java language stuff. We saw it with Hibernate and those technologies, finally making it into Java EE and then displacing the old EJB technology. We saw it with poseless garbage collectors, which Azul, really spearheaded, and now there's poseless garbage collectors inside of OpenJDK. And so, I think with so many different companies having their own builds of OpenJDK and really getting expertise, actually building the JVM itself, it really sets all those companies up to do interesting new things. So, for example, one of those things is Crack, right? Which is a project that we started here at Azul. I know Crack. It's funny. Crack stands for Coordinated Restore at Checkpoint. And basically, there's a feature inside of Linux that allows you to take a snapshot of a process and then rehydrate that somewhere else, right? And one of the things we're doing is, we've introduced some APIs that allow you to take a snapshot of a Java process. So you can run a Java process to the point where it's warmed up and so forth, take a snapshot out of it, and then you can launch new instances from that snapshot in milliseconds rather than in seconds, right? And that's gaining a lot of uptake in the community. AWS is using it for some of their lambdas, the lambda feature called Snap Start, and Quarkus, Micronaut, and Spring Boot are all supporting it to various degrees. So we're very excited about that, and I think it comes from lots of different people kind of getting in the JVM game and being able to work with it to make it work better for cloud native computing, and then a lot of those things will make their way back into standard Java.
It certainly struck me how much Java has changed, because I spent a long time in other languages and not keeping up with what was going on. And then I came back to that Dev Nexus event, and everything's microservices, there's native images, there's Crack, like you mentioned, there's these JIT offloads like your cloud native compiler. Just so much innovation happening. And like you said, so many different companies who have popped up to kind of drive that innovation. So it's really exciting to see what's happening there in the Java ecosystem. We did have a question come in on the chat from Hybrid Robotics, Dale, one of our longtime friends of the show and the ARM software developer community. He was wondering if you've done any comparisons with the performance of Java on your JVM compared to Python or a compiled language like Go.
No, we focus mostly on Java to Java, so we haven't really done those. I think one of the problems is, how are you going to compare apples to apples, right? You would basically run, you run a Java benchmark, right? Well, you can't run a Java benchmark on Go, right? So it's very hard to see, how would you exactly compare. You would have to write a specific set of benchmarks that were guaranteed to do as much as possible the same things. But people love arguing about benchmarks. So as soon as you put that out, people will be like, "Nah, because you coded it that way, and you should have coded it this way," and it would be flame war galore. But I'm happy to if your friends at Hybrid Robotics have some ideas about a good way to do that kind of testing, I'm happy to look into it.
Awesome. And I wouldn't want to wrap up this episode without talking a little bit about Foojay, which is where you and I got in touch.
Yes.
That's over at Foojay, FOOJAY.io, right down there. And that stands for Friends of Open JDK. Is that right?
Yep, Friends of Open JDK. That's right. Yep. This is a community. It's a fantastic community from people all over the Java ecosystem who come together to share information, to share best practices, to find exactly which bits are available where and so forth. We have APIs for discovering what kinds of bits you can download for various platforms. And it's just been great to be a part of. I'm a big, I started out at Sun. I'm, a big community guy. And so I worked on Java.net for a long time, Planet NetBeans and all that. So it's really nice to have a space, where the community can just hang out, share information, and bring these things together. So.
It really is. And there's a Java on ARM channel there that I hang out in. So
Yep.
I should mention there's a Discord. There's a Foojay Discord that we're in that has that channel.
Cool.
And they can find that Discord on the website, right? That Foojay.io?
Yes, it's there on Foojay.io.
Fantastic. And where can people get started using Azul's tools?
Mm-hmm. Yeah, if you just go down to Azul.com, you'll see the download there. A lot of people are using Zulu already, the core product already. We have Prime there as well. Prime you can use for testing and development and kick the tires on it. Same thing with Optimizer Hub. You can set that up. It's just simple Helm chart that you run in Kubernetes to install it all and get it working. So and definitely, we'd love to hear from you. Reach out to us and tell us what you're doing on what your experience was on the platforms.
Awesome. Let's see, Dale just asked if Azul has a Discord. So yeah, Dale, as I mentioned, go to Foojay.io and go find their Discord server, and you can join that, and you'll see me there. So come say hi when you join. All right, John. Well, it's been great having you on. I love learning about all of the stuff that's going on in these language communities and seeing the innovation that's going on, specifically the stuff that's happening around making things work better and faster on ARM. So thank you so much for coming on and giving us all an update on that. And I do look forward to talking to you more in the Foojay Discord, and maybe next time we're all at a conference together.
Awesome, Michael. Thank you for having me, and keep up the great work here. And yeah, look forward to talking to you again.
All right. Shameless plug time. Join our Discord server. That's discord.gg/ARM software dev. Also, take a look at our developer hub and our learning paths, where you can find all kinds of tutorials and other content to help you get started developing more on ARM architectures, ARM servers, ARM devices across the board. John, any ending plug that you want to give?
No, just go to Azul and go to Azul.com and check out Prime, see if it works for you.
All right, and you can find John on LinkedIn. We've got his LinkedIn here too as well. So go follow him there. All right, thank you everybody for watching. And once again, we do these shows every week. We're not going to do it next week because that's Thanksgiving in the US and we're all taking a bit of a break. But we will be back again the following week. So again, remember to hit that subscribe and that like button so that you can see those episodes as they come out. Join us on our Discord, join the Fujay Discord, and we'll continue the conversation there. Thank you, John. Thanks to everyone for listening. We'll see you next time. Bye.